Hi, we're Team 22090, and our project this year was a liquefied natural gas receiving terminal.
Hi, I'm Chris Bonnell.
Hi, I'm Shane Robertson.
Hi, I'm Josh Swisher.
Hi, I'm Chase Stewart, and we're all students in the Chemical Engineering Department at the University of Arizona. Natural gas is an important energy source for the United States, accounting for roughly a third of the primary energy consumption in the U.S. It is also significantly cleaner burning than coal, and it only produces about half of the emissions. Demand for natural gas continues to grow as the U.S. moves towards cleaner energy and the demand increases. Liquefied natural gas has a volume that is 600 times smaller than it is in its gaseous state. This allows for liquefied natural gas to be easily transported by tanker and can provide opportunities for distribution where the current pipeline cannot.
The objective of our project is to design a liquefied natural gas, or LNG, receiving terminal sited on the east coast of the United States of America. The LNG must be offloaded from a carrier ship into storage tanks, regasified, and sent out to a distribution pipeline. It must be capable of achieving variable send-out rates to match seasonal demand. Shown to the right is the process flow diagram, known as PFD, of our design terminal. Included within it are all major lines and equipment used to store, pump, recycle, vaporize, and burn LNG. The major equipment includes unloading arms, full containment storage tanks, a compressor, pumps, a flare stack, and a submerged combustion vaporizer. Our piping and instrumentation diagrams provide more in-depth details on the equipment and the safety features implemented in our design. Our tanks are designated as full containment. This design includes a space between the inner and outer shells that can contain liquid spills and regulate vapor releases. The main construction elements utilized in a tank are an inner tank made of 9% nickel steel alloy, a layer of perlite insulation, and a concrete outer shell. Other elements of the tank design include lines for release of boil-off gas, known as BOG, recycle lines to prevent tank rollover, and both internal low-pressure pumps and external high-pressure pumps to regulate flow of LNG out of the tanks. In addition to all this equipment, safety measures have been designed into the storage tank configuration, including level, temperature, and pressure transmitters with their associated control systems, and valves that are activated based off responses from these systems, both manually and automatically.
During various points in the operation, a small portion of the LNG will begin to vaporize throughout the system. At normal operation, the tanks will generate roughly 4,000 kilograms per hour of boil-off gas. The total boil-off gas rate may be increased during offloading of LNG into the tanks and when first starting up the plant. There are a number of options to deal with this bog. However, we've chosen to compress the boil-off gas with a centrifugal compressor to provide fuel gas for the vaporizers. Centrifugal compressors are commonly used throughout the LNG facilities and are easy to maintain and repair. The boil-off gas will be compressed to 35 psig and delivered to the fuel gas headers directly. The compressor has been designed with considerations to the suction and discharge piping. Emergency shutdown valves have been included and are operated based on level, temperature, and pressure transmitters.
A submerged combustion vaporizer was chosen for this facility. A hot water bath containing the stainless steel tube bundles is heated by burners, vaporizing the LNG. The primary tube bundle supplies natural gas to the pipeline, and the secondary bundle supplies fuel gas to the vaporizer's 12 burners. The burners receive a combination of vaporized LNG and compressed boil-off gas from the tanks as fuel for combustion. The SCV is extremely thermal efficient, near 100%, and offers quick startup and turn down to meet demand changes. The control system monitors the temperature, pressure, and flow. There are pressure relief valves and safety shutdown systems to protect against process safety hazards. The process shuts down for extreme low or high temperature, pressure, or water level. The primary safety concern at the receiving terminal is fires and explosions. Preventing the formation of flammable mixtures is extremely important. The tanks are a significant fire risk in the event of any spill or leak. They are designed as full containment tanks to prevent any air from leaking in and to prevent any LNG spilling out. The tanks are fitted with level monitors and alarms to prevent against overfilling. There is also a constant recirculation of LNG to prevent rollover and the subsequent rapid vaporization that could overload the boil-off gas lines. During startup, the entire process is inerted using liquid nitrogen. This purges the system of air as well as cools it in preparation to receive LNG. For shutdown and emergencies, there is a flare stack on site where any excess natural gas can be safely burned and vented to the atmosphere. In addition to these engineered safety features, work procedures and safe operations will greatly reduce the risk of a fire or other safety hazards at the terminal.
To estimate if this process is profitable, we completed a cost analysis of the system, calculating the costs of building, operation, equipment, and safety features. It revealed that the project can be completed with a profit after a 3-year building period and 10 years of operation. The majority of the profit will be seen in the winter months as demand for natural gas increases and there will be more natural gas delivered to the pipeline. While it currently runs under known federal codes, we acknowledge that we may have to change aspects of the design to fit any future regulations set into place.
We've all learned and grown so much throughout the course of this project. We'd like to extend a huge thank you to our mentor, Bob Simmel, our professors, Adriana Brush and Kim Ogden, as well as the U of A's Department of Chemical and Environmental Engineering. If you have any questions about our project, please reach out to any of our team members, and thank you for watching.